Sir, good morning, sir. Surendar Singh, sir.
Good morning, Dr. Surendar.
Sir, I
Good
think.
morning, Shobana.
Good morning, sir. Good morning, Dr. Sir.
Yeah,
Rajan, sir.
he is connecting. Let us wait.
Yeah, sir. Sir Rajan, sir?
Yeah.
Sir,
Tell
can
me.
we start, sir? Or
Yeah,
shall we
yeah.
wait for 5 minutes?
I think only 23 has joined. Like, shall we wait
Yes, sir.
for 5 more minutes, Surender?
Yeah, we can wait. Definitely, we can wait.
Yeah, please.
Yeah, sir. Fine. Thank you, sir.
Sorry, better I can start. People join because today the exams are going on. That's why I think there is at least yes, yes.
Yeah.
Surrender, sir.
Yeah.
Sorry, I think they slowly join because we have the practical exams of university going on today. So
Okay.
that's why I think the strength is less. I think people join. I requested. Okay, you can start, sir.
Yeah, sure.
Yeah, sir, fine. So, good morning to everyone. So, welcome to the day 4 of SCTP Phase 2 program. So, without further delay, let us start the session. I just hand over the session to Dr. SINGH, sir, who is going to deliver his lecture on the topic Inducing Sustainability in Rigid Payments through Recycle Aggregates.
Thank you, Shobna. Actually, that lecture we have covered yesterday. So I told
Yeah,
you, yeah.
please
So
change sustainable. Yeah, please you announce. You please announce the topic, sir.
yeah, yeah.
Yes,
Thank you, thank you, thank you, thank you. Very good morning to everyone. So yesterday, what we discussed yesterday, we discussed on a few of the things like uh, first thing, fundamentals of the aggregates. Then we discuss how to induce the sustainability with the help of some recycle aggregates. And today is the most important topic is that how to design those sustainable concrete mixes. Right. See, we know the fundamentals of the aggregates. Now we know how to decide whether we can use some recycle aggregates or not. And the most important thing, can we produce a concrete matrix with the help of these innovative materials or not? Okay. So today's topic will be sustainable cement concrete pavement mixes. Here I am hoping that the participants will get to know how to design the pavement mixes. Usually what happens, most of the persons will be thinking that the building concrete as well as the pavement concrete are of same nature. It's not like that. Okay. Yesterday also we discussed that pavement mixes is a little bit different. We need the thixotropic property from it. Okay, yeah, other properties are also important, but we need the thixotropic property because we'll be directly removing the formwork just after placing the concrete. We'll not be waiting for 24 hours. So the concrete need to stand, the edges need to stand. Okay, and also we are designing based upon flexural strength, not the compressive strength, which is a usual thing in case of the buildings. So today we'll start with the introduction and then we'll go with some of the fundamentals and then we'll see how to design the pavement quality concrete, how to design the dry-in concrete, how to design the roller compacted concrete and how to design the interlocking tile blocks. Okay, so in India we can see, okay, everywhere we have the pavement quality concrete and dry-in concrete as a base course. And then we have the roller compacted concrete. Nowadays it's a recent development and you can see the interlocking tile blocks everywhere. So if you are a transportation engineer, you should know how to design these mixes. Okay, it's not a difficult job. Okay, it's very simple. And today we'll be learning how to design these things and how to induce the sustainability in it with the help of various materials. So if I talk about the pavement section, so we can see the cross section of a typical pavement will be, it will be having the embankment, it will be having the subgrade, it will be having the two layers of the GSB. Okay, remember two layers of the GSB. One GSB as a separation layer and the other as a drainage layer. Okay, the separation layer will be separating the upper layers from the subgrade. Okay, that's why it's little bit denser. And for providing drainage, we provide again one gap graded GSB layer. Then we provide a base course, or we can call as an upper sub base course, named a dry link concrete that we discussed yesterday. And then we have the pavement quality concrete slab, and in between, to provide the debonding, we'll be having a plastic sheet overhead. Right. Now the question is that how to design the different layers of a pavement. So if I talk about the subgrade, then we are designing the mixtures based upon the California bearing ratio value. You must be all aware about the CBR value, right? Similarly, for the embankment, we design based upon the CBR value. I think somebody need to mute. Okay, somebody is unmute. Please mute the participant.
Please mute. I think I'm.
Yeah, now it's okay. Now it's okay. Thank you. And then for the subgrade also, embankment, both we design based upon the CBR value normally. Okay, the mixture. I'm talking about the mixture, not the design of the pavement. In case of the design, we design based upon the modulus of subgrade reaction value. Okay, that is K value. So, and then if I talk about the GSP, we again design based, the mixture we design based upon the CBR value and the permeability. And as far as the dry link concrete, we design the mixture keeping in mind that it should achieve some compressive strength at 7 days of the curing. Okay, and for the top slab, That is the pavement quality concrete slab we design based upon the flexure strength. Okay. Earlier, we were designing based upon the compressive strength. But remember, if you are a transportation engineer, you should design based upon the flexure strength. Okay, and there are other criteria also like abrasion resistance, like durability. But we hope that if we are getting the advocate flexure strength, then because the strength is directly proportional to abrasion resistance and durability, we'll be achieving it. Okay, but if it is a special case like we say Tamil Nadu or coastal areas, then we need to design keeping some of the durability parameters. But all over the India, what we can say in a nutshell, we should design based upon the flexure strength until and unless it has been specified in your tender. So what are the various codes? There are various codes. Okay, like if you want to design the subgrade or the GSB, you can refer IS 2720. Okay, if you want to know the permeability of the drainage, there you can refer IS 2720 part 36. If you want to design DLC, you have to refer IRC SP 49, that is Indian Road Congress Special Publication 49. If you want to design the pavement quality concrete, you have to consider IRC 44. And for roller compacted concrete, we have recently updated this, and it will be coming in few months. That is IRC SP 68 second revision. It will be coming soon. Okay, so now coming to the fundamentals. Okay, so we'll be first discussing the pavement quality concrete. So obviously, see what happens. Let's say I'm sitting in my IIT laboratory, right? And I have some contractor is coming to me asking to design a pavement for expressway. And we know expressway is very important. So what I'll be doing, I'll be asking them the materials and then I'll be doing the mix design. Okay, so let's say the contract, what we want for the expressway, it should achieve 4.5 MPa flexure strength at 28 days curing at the field condition. Okay, but remember, I'm sitting in my laboratory. I have my AC. The temperature is 27 degrees Celsius. Okay, and I'll be working with a small amount of mixture. I'll be measuring the water in the pipette. Okay, a capillary tube. But what is happening at the field? The scenario is completely different. Okay, there will be hotness, there will be wind, they will be measuring the water in buckets, they will be throwing it in the mixture. So you cannot compare the laboratory conditions with the field condition. So obviously you need to take some factor of safety. Okay, you have to take some factor of safety. So how to take the factor of safety? Let's say you have to achieve 4.5 MPa strength at the field. So you have to take factor of safety. You can take how to determine, quantify that factor of safety. You can simply multiply it by 1.65 into standard deviation. Okay, normally what happens, let's take an example. Okay, I have seen your feedback yesterday, most of them are the assistant professors. So you took some exam. Okay, so and then you'll be seeing that some of the students secured 100 marks, some of these students will be securing 1 mark, and most of the time the average will be around, let's say, 60 marks, right? So, and then these are the standard deviation. Let's say this is 50 marks, this is 70 marks, and keep on. So we'll see that the marks distribution will be a normal distribution. Similarly, if you are taking 100 specimens, let's say 100 cubical specimens you are taking, and you are testing. So it's not like that all these specimens will be having 100 MPa strength or 40 MPa strength, right? Some of will be having lesser strength, some will be having higher strength. But as an engineer, as a designer, we have to achieve minimum strength at the site. So for achieving the minimum strength we are referring to the characteristic strength, and the characteristic strength is that strength below which only 5% of the test specimens are expected to fail. If more than 5% are failing, that means that is not the characteristic strength. So in a nutshell, what you can remember, that the characteristic strength is the minimum strength that need to be achieved at the field condition. But when you are designing it, you have to take some factor of safety. So you have to design for a higher strength. That higher strength will be known as target mean strength. Okay. So how to calculate the target mean strength? We have two models, right? One model is the target mean strength is equal to strength that needs to be achieved at the, hello?
Sir, sir, just a minute, sir. Sorry for disturbance. Can you just show the previous sketch for 2 minutes, sir? Just 2 minutes. 1 minute, sir.
What happened? I'll be sharing my presentation slides, right?
Just this one, sir. Other things I have.
I didn't get.
Thank you, sir. Thank you, sir. I can proceed.
Yeah, I'll be sharing my presentation with you, all of you. So whenever you want to write something, you can write it down. Okay. Yeah. So what is happening that we have two models. Okay. So when you're designing, okay, you have to decide the target mean strength. So what should be target mean strength? It's not like you have to achieve 4.5 MPa. You are taking 5. You are designing for 5 MPa. It should be not like that. Okay. We don't know at the field what could be the condition. So we'll be taking a higher factor of safety. Okay. So we have two models. Whichever model is giving you more strength, you have to design for that strength, and then you'll be assured that at the field, because of the ambient condition, you can achieve the minimum strength, recommended strength, that is 4.5 MPa for expressways. Okay, why I'm teaching this thing? Because it is one of the most important thing. The engineers, okay, they are not knowing about the design. They think that the design is very, very typical. Yeah, definitely the design is little bit difficult, but today we'll be learning how to design in a good manner, in a simpler manner. Okay, so now how to calculate the standard deviation? This question is that how to calculate this standard deviation. So let's say nowadays different mixtures are coming. Okay, so let's say it's a big project, it's a big expressway. So you have to decide the standard deviation for each mix. So how to do it? You ask the mixture agency. Okay, when the mixture RMC will be coming, you make 30 specimens. Okay, you make the 30 specimens and then you use this model in order to calculate the standard deviation. If there are two RMCs are coming having different mixtures, but strength is same, different mixture means, let's say in one of the columns, or in let's say in DLC you are using fly ash, in PQC you are not using, something like that. Okay, so then you can use this formula. Okay, these formulas are simple. What is that? N is equal to how many number of specimens you are considering. Let's say 30, then 30. Xi is your the observed flexure strength. Okay, and X bar is your average flexure strength. So that is average of 30 specimens. And you keep on doing it, you will be getting the standard deviation value. Okay, so if you are not able to remember this formula, or let's say you'll be saying that my site is very small, or I don't know. Okay, I have to design the mixture, but I don't know what will be happening. So what you can do, IRC 44 provides you with the liberty to directly take the values from the table. The tables are given in IRC 44. So if you are designing the pavement based upon the compressive strength, when your strength is between M10 to M60, M10 here means 10 MPa strength at 28 days, 60 means 60 MPa strength at 28 days. That's why we are writing M60 or M10. Okay, but I suggest you don't go with the compressive strength because it's a pavement. Pavement we need to go with the flexure strength. So if the flexure strength requirement for expressway is around 4.5 MPa to 5.5 MPa, then you can directly take this value of standard deviation at 0.4. Okay, for national highways and for the expressways, always the strength should be between 4.5 to 5.5. Then you can directly remember the standard deviation value should be 0.40. Okay, so now what was the formula? Target mean strength is equal to your strength. What strength you have to achieve? 4.5 MPa plus 1.65 into standard deviation. What is standard deviation? 0.40. Then you will see that the value is around 5.16. That means at this laboratory, when you are designing, you have to design for 5.16, and in the field, the minimum strength that should be achieved is 4.5. That means you are taking the factor of safety. Now the other things is that I have seen many researchers, many faculties in different colleges. What they are doing, they are always casting 100 by 100 specimens, cubical specimens. Okay, 100 by 100 cubical specimens to get the strength value, or they are going with 115 to 115 to 150 mm. But they don't know the fundamentals. Why we are going it? It depends upon the size of the aggregate. Okay, not the maximum size. Yesterday we discussed, right? It should be nominal maximum size. That is, it is the largest field over which around some of the aggregates will be retaining, but not more than 10%. Right? But why? Why it is happening? Because of the wall effect. Wall effect means, let's say we did one test here. Okay, so you are making one cube. Okay, let's say you are making a cube of 100 mm. Right? So what will happen, and you are taking the aggregate nominal size, let's say of 20 mm. So what will happen when you compact this specimen? Okay, when you compact this specimen, so the aggregates will be compacted easily in the interior. But because here there is a steel wall or the iron wall, because the walls of mold. Okay, so because of that, the aggregates could not be compacted at the walls, and this is known as the wall effect. Okay, and when the aggregates are not able to be compacted, so the voids will be higher, and if the voids will be higher, obviously it will be requiring more cement paste. So what is happening? We know cement is the most costliest component, right? And you are sitting in the lab because you are not having 150 mm specimen, you are taking 100 mm specimen mold, and then you are compacting it. 10% extra cement paste is required. Okay, and then you will be getting the strength. But at the field, that 10% extra cement, that means your economy of the project will be significantly lower. Okay, your cost will be significantly rising. So that's why if your nominal maximum size is less than 20, then only you can go with 10 into 10 into 10 mm cubical specimen. If your nominal maximum size is more than 20 mm, to avoid the wall effect, we have to cast cubical specimens of 150 into 150 into 150 mm. Right? Then let's say if I have higher size, then what to do? So normally what is happening for our PQC, what is the size? 31.5 is the maximum size. Let's say 19 mm is your nominal size. So what you do, you multiply it by 5. Okay, so when you multiply it by 5, it will be around 100 mm, then you can go. But if my PQC, the nominal size that has been suggested is 31.5. You multiply it by 5, how much value you will be getting? It will be close to 150 mm, then you can go with 150 mm safely. Okay, so for payments, always go with 150 mm, right? But so sometimes what you will be feeling, you will be going with the cylindrical specimens. Okay, now the cylindrical specimens can be of two sides, 100 into 200, or you can have 150 into 300. Which one to select? It depends upon the nominal maximum size. So what you do, you keep the diameter like 150 mm, divide by what is the nominal size, 31.5. It should be more than 3. If it is more than 3, then only you can select this diameter. Okay, and when you are going to the site, okay, when the pavement has been constructed already, and then you are cutting the course. Okay, so most of the times what is happening, we are not able to cut the course, especially from the dry link concrete, right? It is the base course. So how to cut a core? Okay, if your pavement thickness is more, so you have to ensure that the height of the specimen divided by the diameter of the specimen should be minimum equal to 1. If it is not, then you cannot test that specimen. Okay, these are some of the fundamentals which will be very much required when you are in the field, right? And then when you are testing your cylinders, and somebody will be testing their cubes, and the students will be happy. The students who are working with the cubes, they'll be happy. They'll be saying we are getting good strength. And the students who are working with the cylindrical specimen, they will be not happy, because obviously the cylindrical strength will be 80% of the cubical strength. So at the site, when you are going, you are taking out the cylindrical specimens, and sometimes, and what you have did during construction, you fabricated your cubical specimen, there will be deviation, okay, because of the shape effect. Okay, if I talk about the flexure strength, normally for the PQC, we design the PQC, that is pavement quality concrete, for flexure strength. Remember, for the field, for the pavement, we always have to decide based upon the flexure strength. Okay, so the flexure strength we have, this is the flexure specimen, prism specimens we talk. Okay, similarly to the cubical specimen, when your nominal maximum size is more than 20, for PQC it is 20, right? More than 20. You have to always go with 150 into 150 into 700 mm. I've seen many research papers where they are going with 100 into 100 into 500 mm, despite their nominal maximum size is 31.5, which is wrong, right? And the other thing what I have seen, I discussed it yesterday also, in structural laboratory you will be having 3-point bending apparatus. In transportation laboratory we have the 4-point bending apparatus. Okay, so when you are designing your structures, it is 3-point bending. When you are designing your pavement, it should always be 4-point bending test. Why? Because our pavements are always failing in pure bending. Okay, this is the pure bending where there is no shear force. But if you are evaluating the strength by virtue of the 3-point bending, you can see there is some shear force is also having. at the mid level. So that means it is not okay when you are going with payments. Okay, right. Now, some of the fundamentals you will always be aware of, like what are the various factors. Let's say one contractor is coming to me and then he is asking, sir, I need 4.5 MPa strength, but I am not able to achieve it. What should I do? The first question that will be asking, why don't you increase the cement content? Right? This will be thing, right? Why don't you increase the cement content, or why don't you decrease the water content? So that means the most dominating factor will be the water by binder ratio. Remember, I'm not using water by cement ratio. Earlier we were using water by cement ratio. Now we are using water by binder, because nowadays we are using fly ash, we are using PPC, we are using slag cement. That's why we say as water by binder ratio. So if you see here, as the water by binder ratio is your increasing, that is when your water by binder, let's say I'm writing cement for the simplicity, when my water by cement ratio is increasing, what will happen? How it will be increasing? Either the water is increasing or cement will be decreasing, right? So when the cement is decreasing, that means obviously your strength will be decreasing. So this law is known as Abraham's law. We state that if you want to increase the strength of your concrete, you decrease the water by cement ratio. Okay. And the second most important thing is the degree of compaction. Why degree of compaction is important character, one of the important parameters? Because let's say one of the field engineer, he has used 300 kg of cement. Next time he used 400 kg of cement. Next time he used 500 kg of cement. Then also he is not able to get this strength. Why? Because at a constant water by cement ratio, if you are not able to compact your pavement fully, then you can get three different strengths. The strength can vary from 60 MPa to 20 MPa. Okay, because of the poor compaction. That's why compaction is very much required. You have to do the proper compaction. And the third thing is shape of the aggregate. Okay, so if you are having angular aggregates, you can see angular aggregates, aggregate to aggregate interlocking will be there. The voids will be lesser, so the cement paste requirement will be lesser, and the strength of the concrete will be more, because strength of the aggregate is more, right? Similarly, if you are using well-graded aggregates, right, the porosity will be lesser, strength will be higher. And the size. Yesterday also we discussed. Sometimes what we discussed yesterday, that the nominal size of your aggregate, okay, should always be divided by 3 to 5. The thickness of your pavement slab divided by 3 to 5 should be the nominal maximum size, because we need the good aggregate interlocking. For that, the nominal maximum size should always be lesser than the thickness of your pavement slab divided by 3 to 5. Why? Because if you increase the size, obviously the cement paste requirement will be lesser, but the bonding between the cement paste and your aggregate will be very, very poor, right? Because bleeding water will be there, and if the bleeding water is there, your water by cement ratio, that means if the bleeding water is coming, the water will be increasing, so the water by cement ratio will be increasing, and you will be getting the lower strength. Okay, and similarly, the ratio of coarse aggregate to fine aggregate is an important parameter. And nowadays, see, you will be having this question, why we are using fly ash. Okay, sometimes I'm very afraid if I use the fly ash, it is not giving me this properties, or it's a waste material. Why to use it? So the fundamental is that when you are adding cement with water, you will be having two hydrated products named as calcium silicate hydrate and calcium hydroxide. This calcium silicate hydrate will be giving you strength, and this calcium hydroxide will not be giving you anything. It's a durability concern will also be there. So I know for my strength I need CSH, and this is a byproduct CH. Can't I convert into CHS? Yeah, obviously you can convert it. You have to add externally S from outside. So whatever waste materials that you want to use for replacement of cement, you can use it, but it should have silica in it. Fly ash is having around 70% silica. Silica fume is having around 90% of silica. That's why when they are used, they will be increasing the strength, as well as they will be reducing the durability risk. Now the other question is that we have two approaches: weighing approach and volume approach. Okay, you have seen at the site what is happening at the site. Okay, like for normal construction, for house construction, they will be using some pans. Okay, in Hindi we call it as a tasla. So they will be filling it, okay, and then they'll be dropping in the mixture, right? But you have seen that when they are taking the aggregate, they'll be filling the pan fully. But when they are taking the cement, they'll be keeping it lesser. Okay, that means volume batching is not good at the field condition. But when you are a researcher, when you are the designer, then weight method is not good. So which method is good? You are saying at the field volume batching is not good because they will be using the same bucket for cement and aggregates, and cement they'll be filling it lesser, for aggregate they'll be filling it more. So the mix design will be changing, right? But for the designer, weighing method is not good because let's say we have two aggregates, same size, okay, but one aggregate is having porosity. Okay, so if the one aggregate is having the porosity, let's say some recycle aggregate. Yesterday we discussed that recycle aggregate will be having lesser specific gravity. And if you are following the weighing approach, so what will happen? Let's say one heavy aggregate will be equal to, it's a hypothetical condition, okay, two porous aggregates. And when you are keeping it in the concrete formwork, it will occupy the same space because the shape, the volume is same. The shape of the aggregate is same, the size of the aggregate is same, so it will occupy the same volume and the concrete will be poor. So that's why we say that the weighing approach is not good. We have to consider the specific gravity of the aggregates. If you are considering the specific gravity, then we can design a very good matrix. But for that means it says that when you are designing, you have to consider the volume approach. But when you are recommending your mix design to the field engineer, then you have to recommend it in terms of weighing approach. Okay, because at this side complications can be heavy. I have few pictures also that I'll be sharing at in the end of the presentation. Okay, so what are the data that will be required? Definitely, I need the specific gravity values. Okay, I'll be needing the particle size distribution. I'll be needing the water absorption capacity of the aggregates. Why? Let's say yesterday night in Chennai it was rainfall. Okay, and you thought you will be making your payment, but because of the rainfall, the aggregates has absorbed some water. Okay, so it will be changing your water by cement ratio. So you should know about this, how much water absorption can be there, and there are many more things. So in world level, what is happening? Okay, everywhere the design of the payment is almost same. Okay, so if you get to know this step, then definitely you can design the payment everywhere across the zone. Okay, so these are the steps. We'll not going into the steps. We'll be seeing a simple procedure. Okay, so what we need from our concrete, we are mixing concrete coarse aggregate, we are mixing fine aggregate, we are mixing cement, we are mixing water, and we are mixing nowadays fly ash also, right? And when you are compacting it, there will be some voids, that is air voids. So as a designer, you have to design this thing. Okay, and then you are designing based upon the volume, and after that what you are doing, you are recommending to the field engineer in terms of the weight. What should be the weight of the water, what should be the weight of fly ash, what should be the weight of fine aggregate, and what should be the weight of coarse aggregate. Okay, if you are using some recycle aggregate, you can add the recycle aggregate also here, right? So how to design it? So remember two things here. You have to design based upon the volume, and then you have to convert the volume into weight. Why weight? Because at the site, volume batching is not considered to be good. Okay, so how to convert volume into weight? You know the formula. Density is equal to your mass upon volume, right? And what is density? Density is nothing but specific gravity into 1000, because we are measuring with respect to specific gravity of water. So if I know the volume, okay, we know the volume. If I know the specific gravity of coarse aggregate, fine aggregate, cement, okay, then I can get the mass. This is the simplest formula that you have to remember, and you can design your payment. Okay, so we discuss here it. Okay, so what is the step? So first of all, you remember this photo, okay, this picture or the schematic. We have to decide the volume of air, volume of water, volume of fly ash, volume of cement, volume of fine aggregate, volume of coarse aggregate. We have to design, and then with the help of density is equal to mass upon volume, we have to convert it into weight. So in a nutshell, we have to recommend in terms of the mass of coarse aggregate, fine aggregate, cement, or whatever the other material that we are using. So how to do it? So one by one we'll be finding it out. First thing is air. How the air is coming? When you are compacting your aggregates, when you are compacting your mixture, okay, there will be some voids. So how to decide? You don't have to decide. There is a table given in IRC 44 specifications. Okay, based upon your nominal maximum size, you can directly read the air void. And remember, for PQC, the nominal maximum size is 31.5. So you can directly remember this value 0.8. It's very simple, right? What is the next step? You have to calculate the water, you have to calculate the fly ash, you have to calculate the cement. Okay, so how? Let's say we know water by cement ratio. Okay, that is the important parameter we discussed in the factors affecting. It is more dominating parameter, right? So there is a table given in IRC 44, and we know for my expressway. This time we are designing the expressway, right? Expressway, let's say the strength requirement is 5 MPa. Okay, and you are using cement OPC 43 grade. So from the table you can get the value of 0.34. This should be the minimum water by cement ratio that you have to use. Okay, so you got the minimum water by cement ratio that you have to consider is 0.34, right? So this is 0.34. Okay, so now if I can able to get either water or cement, because I have already the water by cement ratio, then I can decide the cement also, right? So the first thing is water. How to decide the water? Again, there will be table, because the IRC 44 is providing you everything. You just need to know the fundamentals and the design procedure. We know water is being affected by many things that we have discussed. Okay, so like if you are increasing the cement content, so what will happen? You will be needing more water. If you are increasing the size of the aggregate, you will be needing lesser water because of the lesser surface area. If you are using round aggregates, because round aggregates are having lesser surface area, right? So they will be requiring lesser water. If you are using super plasticizer, you will be requiring lesser water. So there are many factors on which the amount of the water will be affecting. Okay, so these are the fundamentals. If you want to learn, you can learn, or else there is a table given in the IRC 44 which says that if you are designing your PQC mixture whose nominal maximum size 31.5, you can directly get the water from the table, okay, which is 165. But remember one thing, this table is valid for a slump value of 50 mm, and for PQC our slump value requirement is 25 mm. Okay, so obviously if this water is corresponding to 50 mm slump, if you want to reduce this slump, what we have to do? We have to reduce the water, right? So how much of the water we have to reduce? We have to reduce the 3% of water. Okay, so our water by cement ratio was 0.34, right? Our water was 165, but we have to reduce it by 3%. So what should be the water? 0.97 multiplied, you will be getting the water around 158 kg. Now if I get the water, I keep the water here. Okay, I bring this one here, I can get the cement value. And then you have to check that the cement value, the minimum cement value should be 360 kg and the maximum cement value should be 450. Now this is a twist here. As a student, okay, as a field engineer, I think that if I keep on increasing the cement content, my strength will be increasing. But IRC is asking you, no, you cannot increase the cement content beyond a particular limit. What is the reason? So if, and I'll not be telling you the answer, maybe if some of you knows the answer or you can guess it. See, in my class you can guess anything. Until and unless you are not guessing it, that means you are afraid or you don't know or you are not getting what I'm teaching here. Okay, so there is a chat box. I request all of you to open the chat box and keep writing the answer. My question is that why there is a limit on maximum cement content? Okay, that is 450 kg. Why can't I use 500 kg? It will be good. It's my money. It's my cement. I can do it. I need good strength. But why there is a limit on the maximum cement content? Right. Now the next thing is that this is the sustainability aspect. Nowadays we are using fly ash. Okay. So government says that, the ministry says that you can use fly ash up to 30%. Let's say you are using 20%. Okay. Your cement content came out to be 400 kg, let's say. And the ministry says that you can replace cement by fly ash in a proportion of 20%. So what should be this fly ash content? Obviously, what you will be doing, you will be multiplying by 20 and you will be saying, yes, we can use fly ash as 60 kg and then 320 we can have the cement content, right? This is normal procedure. what you are thinking, because the ministry is saying that you can replace the cement by 30% of fly ash, or let's say 20% I am using for this example. So what should be the fly ash? Okay, 400 kg is cement. They are saying that 20%, so you multiply it by 20, you got 80 kg. If you are using 80 kg of fly ash, then obviously 400 minus 80, that is 320 kg of the cement you are using. But this is the wrong procedure. Okay, remember, nowadays it's a recent advancement of the fly ash, you should know. See, remember we discussed that when you are adding water with your cement, okay, you are getting CHHL and you are getting CHL. Okay, so what you are doing, you are adding fly ash from outside, it will react with CH, okay, converts into CHHL. That means it's a cementitious particle material, right? So every waste material, any waste material will be having different cementitious content. So if we have to come to the laboratory, we have to think how much cementitious content it will be giving me if I am using some supplementary cementitious mineral admixture, that is SCM. Okay, if you don't have any value, if you don't have the laboratory, simply you can increase the cementitious content by 10%. We'll take an example. Let's say we have 400 kg that we were using. Okay, now if I'm using fly ash, let's say 20%. So I can see without any experimental data, I'm thinking that with the help of the fly ash, I can increase the cementitious content by 10%. Okay, so you have to multiply by 1.10. You'll be getting a value of around 440. Okay, 440. So that means now the cementitious content has been increased. And then with this cementitious content, now earlier, how much cement you were using? 400 kg. But because you are using 20% fly ash, your cementitious content will be increasing by 10%. Now your new cementitious content will be 440. Now replace this 440, 20% of this 440 should be your fly ash. How much it is? 0.80 into 440. It will be no, 352 kg of your cement, and then your 88 kg is your fly ash. See the difference. Earlier, you were having fly ash as 80 only, right? But cement was lesser. Now, your cement is further lesser and the fly ash is increased. That means this is the method. Okay, I can again repeat if you want me. Simplest thing is that you have to come to the laboratory and you have to see how much cementitious content can be increased. If you don't have any information, simply increase by 10%, and then you replace that cementitious content with 20% fly ash, and rest of the things will be cement, OPC. Okay. So now we got the values of air, fly ash, water, and cement. Now what are the things left? It's coarse aggregate and fine aggregate. Here there is a trick. Trick is that we will be calculating the volume of coarse aggregate with respect to fine aggregate. Okay, there is a table given in IRC 44. You don't have to be confused. What is the nominal maximum size? 31.5, right? What is the zone of the fine aggregate? We discussed yesterday that there are 4 zones, zone 1, 2, 3, and 4. Nowadays we are having 3 zones only, zone 1, zone 2, zone 3. We have abolished zone 4. So your fine aggregate is zone 2, your aggregate size is 31.5. Then you have to simply take the value from here. That means this shows that the ratio between coarse aggregate to fine aggregate is 65-35. Simply, it's a simple thing. You don't have to worry for anything. But remember again, this table is valid for a water by cement ratio of 0.5. And in our example, what was our water by cement ratio? It was 0.34. So that means you have to increase. In order to get more strength, you have to increase this ratio of coarse aggregate to fine aggregate. How to increase? It's given here. They are saying that if you are reducing your water by cement ratio, this water by cement ratio by 0.05, you have to increase this content by 0.01 meter cube, right? And if you are, in our case, what is the value? 0.34. So by how much we are reducing our water by cement ratio? By 0.16. So in that case, how much we have to increase this? It is 0.01 divided by, this will be coming here, 0.05 into 0.5 minus 0.32 or 34, whatever it is. By this much we have to increase our content. Okay. So now you got the value. Okay, 1 second, you forget this thing if you are confused. You have to simply read the value from the table, coarse aggregate to fine aggregate. Coarse aggregate 65%, what should be fine aggregate? 35%. Okay, that's it. So now you got everything. But now, if you remember correctly, in the previous slides, we were getting water in kg, cement in kg, okay, and now you are getting your volume of coarse aggregate and fine aggregate in proportion, 65-35. You have to convert it. How to convert it? We have the simple formula, okay, that we have discussed. That what we have to do, this is the mixture that you have to decide. You have to give a mixed design to the contractor in mass. Okay, now you have calculate and you have to calculate the mass of fine aggregate and coarse aggregate, but we don't have it. What we are having here, the coarse aggregate is 65%, fine aggregate is your 35%, right? What to do? So simply what we can do, I'll assume that the total volume is V or 1 meter cube. The total volume is 1 meter cube. Okay, I know the mass of water, I know the mass of fly ash, I know the mass of cement. Okay, right? Can I convert this into volume? Yes, obviously, we know density is equal to mass by volume. I know the mass, I know the density. What do you mean by density? It is specific gravity into 1000, right? So, how to convert the water in the mass of the water into volume? What is the specific gravity of water? Is 1. 1 into 1000, and then it will be coming volume is equal to mass by density. Okay. Then how to calculate the volume of cement? Volume of the cement, I have the mass of the cement at 400 kg, right? What is the specific gravity of cement? 3.15, you can get the volume. So what I mean to say, if I take the total volume as 1 meter cube, if I know the volume of air, volume of water, volume of SCM, volume of cement, so if I subtract this volume from the total volume, I'll be getting the volume of coarse aggregate and fine aggregate, right? And we already have the proportion 65 and 35, and simply we can convert it into mass by the help of this same formula. Okay, see, because of the paucity of the time, we will not be able to cover everything, because in my normal classes also, I'm covering mixed design in around 5 to 6 classes. Okay, so I'll be sharing my presentations with you. You can go through it. Let's take a quick example. Okay, this is the design that we did for a expressway. Okay, the contractor came to us and asked that they need a flexure strength of 4.5. Okay, and they said the nominal maximum size of the aggregate is 31.5, and they are going to use OPC 43, and they are also going to use superplasticizers. Okay, and I asked them, how is the degree of supervision? He said, yeah, it's fantastic, it's good. Okay, so that means they don't want to take higher factor of safety, because the supervisor is the experienced one. But then also we have to take higher factor of safety, right? We don't know the environmental conditions. So what I did, I asked them the aggregates. They gave me the aggregates. They gave me the cement. I calculated the cement, specific gravity of cement, coarse aggregate, fine aggregate, water absorption, everything I calculated it. Okay. Then first thing is that it's a expressway. I don't want to take any risk. We need to take factor of safety, right? So we have to design for target mean strength. How much time he asked from me? 4.5 MPa, right? So, and what should be standard deviation value? I directly read it from the table, that is 0.4. If you keep this 0.4 here, you will be getting 5.16. So that means I have to design the mixture at 5.16. Then only at the field 4.5 will be achievable, right? First step over. What was the second step? I have to give the mass of water, SCM, fly ash, fine aggregate, and coarse aggregate, right? So I'll be going step by step. First thing A. Okay, we can directly read it from the table, because in that expressway they were using aggregate size of 31.5, and what should be the air? It is 0.8%. Third step was water by cement ratio. Okay, what was the strength that we required? Is 5.16, right? We are designing for 5.16, and the table says that if it is 5, you have to keep the water by cement ratio as 0.34. If it is 5.5, you have to keep it 0.28. But my value is intermediate, so I have to do the interpolation. I did the interpolation. I found that the water by cement ratio that I had to select is 0.32. Okay. Okay, so water by cement ratio, we got it. Now water. Okay, we already discussed that you can directly read it from the table at 165 kg. But here there are two things. One, that this table is valid for a slump value 50 mm, but our slump value is 25 mm. We have to reduce it by 3%. I reduced it. So it came to be 160 kg. Right? But again, the contractor told me, sir, we are using super plasticizers. Okay, and super plasticizers, it will be reducing the water demand. Okay, we did the trials. We found that with the super plasticizer they were using, it could reduce the water content by 20%. That means you have to further reduce this water by 20%. So 160 into 0.8 is 128 kg. This is the water content that I will be getting. So my water by cement ratio is how much? 0.32. I got the water value and simply I can get the cement value. Okay, cement value is 400 kg. So I got water, I got air, I got the cement. Right? Then I have to check that the cement content should be between 360 to 450. Yeah, it is in between. Okay, I again remind you, you have to type in the chat box why there is a limit of 450 kg. Right? Next step is fine aggregate and coarse aggregate. Simply, the tables are already available. What is this zone of fine aggregate? Zone 2. What is the size of the aggregate? 31.5. What should be the proportion? 65%. What should be the proportion for fine aggregate? 35%. And we have to just tweak it because this table is valid for the water by cement ratio of 0.5. In our case, the water by cement ratio is 0.32. So that means you have to increase this ratio by some quantity. And some quantity will be that we already discussed that if there is a reduction of 0.05 in this water by cement ratio, you have to increase it by 0.01. Okay, we wrote it. And then simply, if there is reduction of this much, how much need to be increased? We got this value as 68%. Now, coarse aggregate are 60 and fine aggregate is 72. Now, again, I got the mass of water, I got the mass of cement, I know the volume of air, but I don't know the fine aggregate and coarse aggregate, right? So, what we did, we have assumed that the total volume is 1 kg. If I reduce the volume of these things, let's say volume of this thing V1, we can call as a V1. If I know the total volume, if I know the volume of these things, I can definitely get the volume of coarse aggregate and fine aggregate. How? First of all, we know the mass of water, we know the mass of cement, and we know the density is equal to mass upon volume, and density is nothing but your specific gravity into 1000. We already know the specific gravity. Then we can get the volume of water, volume of cement. If I get the volume of water, volume of cement, I have to reduce it from the total volume. I'll be getting the volume of coarse aggregate and fine aggregate. And obviously, from this table, I already know that the coarse aggregate and fine aggregate proportion is 65 and 35, right? So I can directly multiply it by 65% and 35%. I'll be getting the volume of coarse aggregate and fine aggregate. See, look, it was so simple, right? It was very, very simple. So I have written all these steps here. What you have to do, you have to just go and try to solve this example. Okay, you'll be getting everything. There is nothing so difficult in here, but there are few things. First thing is that you're designing based upon SST condition. SST condition means your aggregates are already soaked in the water. But is it the condition that can be achievable in the site? Yes or no? No. Why? Because you know, at the site, first thing is that they will be doing the volume batching, right? You can see here, this madam is having one pan. Okay, this pan will be full of aggregate. But when the same madam will be going for the cement, she will be having lesser cement. Okay, because the contractor will be asking them. Right? That's why we don't want volume batching at the site. But for designing, we have to consider the volume batching, right? Because of the changes in the specific gravity. And second thing is that, can you achieve SST condition in the site? No. Because SST condition means you have to completely soak the aggregates with water. For coarse aggregate, you can do it, but for fine aggregate, it's nearly impossible. Okay, that's why at this site, we are using the aggregates in dry condition. Now, the mixed design that you did is in SSD condition. How to convert this SSD condition into dry condition? Okay, SSD condition means this was your aggregate, these were voids, it was filled with water. Okay, I have to remove this water, right? So when you are removing this water, what will happen? The weight of this aggregate will be reducing. So simply what you have to do, you have to reduce the weight. You have to reduce the water absorption, and that water you have to add in total water. Why? Because earlier your aggregate was filled with water. Now you are removing this water, right? Your mass of the aggregate will be reducing, right? But when you are keeping in the mixture, then again this dry aggregates will be absorbing the water, right? So it will be absorbing the water from here. So the weight that you are reducing, you have to add it in water, and then your mixed design will be ready. Okay, so this is the mixed design in dry condition. And the last step is drying concrete. See, it's a simple thing. I'll be finishing in 5 minutes. Drying concrete is the base course. We discussed yesterday also. Okay, we design it based upon it's a straightforward design. You don't have to do anything. Okay, so the strength requirement is 10 MPa. Don't go with 7 MPa. It's an absolute code. Nowadays, we are going to design the DLC based upon 10 MPa strength. Simple thing. It's a very, very simple design. Okay, what you have to do, you have to design the coarse aggregate, fine aggregate, cement, fly ash, and the water and the air. Okay, PQC design was little bit longer. This is very short. What you have to do, assume a aggregate to cement ratio. Let's say I'm assuming 10:1. 1 is your cement, 10 is your aggregate. Okay, and then assume cement. Let's say I'm assuming cement. The code says that it should be minimum 150 kg. I'm taking 150 kg only. Okay, so what is my cement value? 150 kg. What will be my aggregate? Aggregate, the ratio that I am taking is 10:1, multiply by 10. That means your aggregate should be 1500 kg. Simple. Okay, now water. How to calculate the water? You know, Proctor test, OMC, MDD. Okay, so you have to calculate the OMC and MDD. You will be getting the water. The simplest thing. And then you calculate the compressive strength. If the compressive strength is less than 10 MPa, then you have to increase the cement content. Earlier we were taking 150 kg, then you have to take 160 kg. See how simple it is. The first step was you assume some aggregate to cement ratio. It should be less than 14:1. I'm taking 10:1. Assume the cement content. How much cement content I'm taking? 150 kg because the code says it should be minimum 50 kg. Then I get the aggregate fraction. What should be the coarse aggregate? What should be fine aggregate? I'll do the blending. Yesterday we learned, right, how to do the blending. We do the blending as per the stipulations. Now we got the cement content, we got the coarse aggregate content, we got the fine aggregate content. The last thing is water. How to calculate the water? You have to draw OMC and MDD curve with the help of the Proctor method. Okay, and then you can do it. Right? It's a simple thing. Similarly, for roller compacted concrete, there is a code named as IRC SP68. For that also, you have to follow the same approach. You have to select the aggregate gradation, you have to select the cement content, calculate the OMC MDD, and here it's based upon the flexure strength. If you are getting the flexure, it's okay. If you are not getting the flexure, you have to increase the cement content. Similarly, for interlocking concrete blocks also, the method is exactly same. Okay, you have to assume the water by cement ratio, right? And assume the aggregate to cement ratio, find out the OMC and MDD value, and then see whether you are getting the compressive strength or not. If you are not getting the compressive strength, you have to increase the cement content or decrease the water by cement ratio. So this was the last slide. I hope, see, usually I am covering everything in 4 to 5 classes, but here I have completed in 1 hour. So I'll be sharing my presentation slides with you. What you have to do, you have to simply go and solve these examples. Okay, I have given the examples. If you have any doubts, you can anytime come to me. I'll be more than happy to resolve your queries. So with this, I would like to say thank you. Okay. And if you have any questions, you can type in chat box.
Thank you, sir. So participant, if you have any questions, you can just post your question in a chat box. Sir will clarify your queries.
Yeah, I asked one question specifically to them. Why 450 kg? So Balakrishnan P replied, durability point of view, cement content is 450 kg. Yeah, shrinkage. Because shrinkage, we are providing the joints in the concrete pavement, right? So why we are providing the joints? To take care of the shrinkage stresses. If you are using more cement, there will be more shrinkage and the chances of the cracking will be higher. So thank you, Balakrishnan ji. Yeah, right. Right, Rajan sir. Excessive cracks may form. If you have any questions, you can type your question. I'll be, I'll try to, clarify your doubt. Or you can just unmute yourself and you can, ask me questions.
So participant Vinay Suresh is from YouTube actually. So he had commented on the YouTube. So we just posted from a sir account.
Okay. Yeah, right. Okay. So they are saying it's uneconomical and nowadays researchers are finding replacement. No, see, economy is a different thing. Shrinkage. The important thing is the shrinkage. Okay, what we have found that if you are increasing the cement content by more than 450, shrinkage cracks are bound to happen, and it will be uncontrolled cracks. You cannot control it, right? So we are providing the joints after every 4.5 meters to 5.5 meters, like normally 4.5 meters, so that we know the shrinkage cracks will definitely be happening, and it will be happening at 4.5 meters, so that we can control it. If we are increasing the cement content further, we will be not knowing where the cracks will be coming, right? Yeah, Milind Rohtas Gupta, water cement should be between 0.3 to 0. Okay, yeah, right. Neeraj Singh for higher grade mixes is M5. M500 is too much. Shrinkage cracks will be more, and does the requirement for joint increase for such mixes? Yeah, right. See, you mean to say M50. Okay, yeah. So you are answering my question. If you have any questions, you can type your questions, or you can unmute yourself, you can ask me questions.
Participant, do you have any questions? You can just unmute yourself and you can directly ask to the Surendra Singh sir. There's no problem. And meanwhile, you can also fill your feedback, which is posted in the chat box as a link.
I think there are no more questions. So, okay, never mind.
Yes, I think the question is over, it seems. Thank you,
No
sir.
problem, no problem.
Thank you very much, sir, for your valuable lecture.
Sir,
Yeah,
sir, about you told you share your PPT, sir. to
yeah,
whom, sir?
definitely. I'll be sharing with Professor Rajan. Then
Dr.
he'll be
Rajan,
sharing.
sir. Yeah,
HOD.
we will be.
HOD, huh? Okay.
Yeah, HOD, yeah, right.
Yeah,
Okay,
we will.
thank you.
Yeah.
Thank you, Professor Rajan. Okay, so with this, I'll say bye. And if you have any doubts, you can anytime email me at surendra@iitm.ac.in. Okay, I'll try to resolve your queries there also. Okay, so thank you very much.
Thank you, sir. Thank you very much, sir. So participant, before starting the session 2 of day for SCTP program, you kindly fill your feedback in the feedback link which is posted in the chat box. So the next session will be sharply start at 11:30 by Mr. Lokesh sir. So meanwhile, you just fill your feedback.